Welcome. I've decided to make a new playlist. It is called CNC Router Beginner to Pro. So depending on your level, you can come and check back later. There are several sequences in this playlist, and I will go all the way from not knowing much about a CNC router, and maybe for someone that has just gotten their machine and is still a little bit afraid of doing this or that, all the way to the pro level where we are going to cut and thread mill in aluminum. Along the way, you will learn how to set up the basics of your machine, the different bits, the different speeds and feeds for material, and how to set them correctly for your machine. And I will show you add-ons that you can add to your machine to make life a little bit easier, like an automatic Z setting tool or like a fog buster, for example. So in this first episode, I'm putting the horse in front of the cart. Instead of doing a lot of theory talk, we're going to start out right with our first project, and that is this toolboard that you see right here next to me. So we're not going to make the drawing. Rather, what I'd like you to do is hop on my webpage, download the file, and then we can start together working on this project. So to make life easy for you, there is a PDF file with all dimensions, so you can draw this on your own if you like. Or if you are not to that level yet, then there's a DXF file that you can download and import into your system. Now, if you work with VCarve or want to try that out, then I also have the CRV file, which actually is the finished project with the tool and all the toolpath in it as well. Hop on my webpage, you can download it there, that way we can start. Now, there are several considerations for this toolboard. It's really simple, it's made of MDF. The smallest hole that we have to put in here is a little bit bigger than 1/8 of an inch. So that you do not have to make a tool change in between, I made the entire project using a 1/8 inch bit. Now, normally you wouldn't do that for pockets this big, but I wanted to avoid the tool change. The second one is that there is no perimeter cut. So we don't have to worry about tabs or holding the project. This is already a board cut out 200 by 300 millimeter, and we are starting out with this board on the table. How do I fasten it onto the table? I don't want you to use screws or clamps, because in the beginning I can tell you they are the killer for bits. Often you're going to run into one of those clamps, and right off the get-go I like to tell you that the safety height here, the safe height, is 5 millimeter above the board. If you clamp from the side, your chances are high to break your bit. Okay, let's insert the tool into the spindle or into your router. The right way of doing that is you take your collet nut and you take the proper size collet, and the collet goes in first like so, and once that is engaged, the tool goes in like this. Now here's the one thing I like to show you, and that is, this is a 6 millimeter collet. That's a 1/4 inch shank. I can force that in here, and that's not a good method, that's not a good way of doing it, because a run out on this will be really bad. So don't do that. 1/4 inch shank, 1/4 inch collet. Next is the stick out of the tool. So in general, we want to have as little stick out as possible. That makes the tool more rigid. And the way you're going to do that is you're going to take the flute, the end of the flute right here, and you take about, half the diameter or the diameter of the shaft, just eyeball it, and that's where you insert that. So the flute comes to an end right there, and that's about the stick out I like to have here. For every project, you will need to set X, Y, and Z 0 in the work coordinate system. The work coordinate system references your part. And for the file that I furbished you, the 0 point is in the lower left-hand corner on top of the workpiece. And depending on what you're cutting, that needs to be sometimes really, really precise. In our case today, it really does not matter, and I don't want you to break the bit. So we're going to stay above the work surface and just going to eyeball the XYZ0. Let me show you. Okay, let's set the z-axis to 0. That will be on top of the workpiece. And what I like you to do is get a little bit thicker material of cardstock, or you can use paper and just fold it over. I want it to be a little bit thicker because no accuracy required today. And then we need to lower the z-axis. You can use your keyboard with it. I have a pendant, so it makes it a bit more convenient for me while I'm sitting here. And you can see already, if I go down, it takes a really big step down, and that is actually 1 millimeter. So I will not be able to set the final Z position this way, because ultimately the bit is going to try to drive a millimeter down into the MDF. So here's a really, really important step, and that is once you get close to where you want to be, this is about it right there, I'm going to change my step to from 1 millimeter to 0.1. Find that in your menu on the jog, how you change the distance for one single step. Okay, so now I'm on 0.1. You can hear it, or I can hear it, but I can hardly see it. So I go down, 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 down. And this cardstock gives us plenty of room between the tip and the MDF. So I feel it, it's scratching it, and this is it. That's the accuracy we need for today's job. Now I'm going to set this value to Z0. So one common way of breaking your tool is right when everything is set, Z0 is set, and you remove the tool from the top surface and you want to go up, but you push down. And that is why today I used the thick cardstock, and what I like you to do next is really to just tap the up button. So whichever button on your keyboard makes the axis move up, that's what I like you to just tap slightly on, even if you still have the small setting instead of a large step. So you're going to hit, in my case, that is page up, and I'm just going to tap it really quickly, and I'm still on 0.1 millimeter. That would mean that I can watch the direction the axis is going. I'm sure it's going up, and now I can hold the button and safely remove the tool up without breaking it. Next, we need to set the X and Y0. Like I mentioned, it's right on this corner right here. And for today, what I like you to do is just to drive the center axis of the bit roughly onto this corner. And we're just going to eyeball that. And so I go to X and 1 millimeter step direction or step distance. And move that over, and I can do that already right here by eyeballing this edge and eyeballing the bit. Okay, that's as close as I have to have it, and I'm going to set this now to X0. I'm going to do the same for the Y-axis, so I'm going to come forward now. And this time I'm going to watch from this direction onto the bit until I have set the bit to roughly the center. There it is. That's close enough. So now I'm going to set the Y0. So we are now in X and Y0. Z0 we have already set. Our setup for the work coordinate system is now complete. So it is difficult for me to judge what type of machine you have, but I wanted to give you some feeds and speeds in the file already ready to go that I know will work on most of the machines there. It will not set a speed record, but it will also show that nothing will start to smoke. So often, if you're a woodworker, you know this already, that if you go too slow with a handheld router, you burn the wood. And the same thing will happen here as well. If you move too slow or you plunge too slow. So we have a feed, and that feed rate is for when we are in the cut, but we also have a feed rate for the plunge. And sometimes that plunge rate is too slow and the bit goes down too slow and just everything starts smoking. We don't want that. So the feed rate here is 800 millimeters per minute, and the plunge rate is 400. In MDF that should work fine. 1/4 inch bit, 15,000, that's conservative. If you have 12,000 it will work, if you have 16,000 it will work as well. Okay, all right, let's hit the start button and see what happens. So here comes the very first pitfall to avoid as a beginner. What we like to do is that we're afraid, we run the toolpath the first time, we don't know what happens, and ultimately we dial down the feed rate, so how fast the machine is cutting, but we leave the RPM up. And that ultimately results in a lot of rubbing on the bit and possibly smoke starting to happen when you cut wood. So things burn. And that amount of heat is really the death of your bit. You don't want to do that. The values for speeds and feeds that I'm furbishing you will be really a minimum. So they will also work, let's say, on a shark or on a machine that is made of plywood. These values on more rigid machines, most likely for the speed and feed, you will be able to quadruple those and still be okay. All right, so don't slow down the feed rate. Okay, this came out good. The collets seem to fit also well. I like it. And the spindle nut, that's okay. Easy to get in and out. These tools seem to fit right here. So that's good. So there's one important thing that I forgot to tell you, and that is that I used double-sided tape to tape the piece down, and I really just literally eyeballed it the way it's laying on the table. The only thing that you have to note is that it's going, the Y direction needs to be the long side of the board. Okay, so if you found this interesting and you got something out of this today and you learned something, number one, please leave me a like if you would. And then number two is please check back for the next video. There's a bit more theory in there. I like to show you how I set up my VCarve Pro. There are a couple of tips I have. I'm not going to go into the drawing detail. There's so many good videos out there. I rather like to show you some of the routines that I have and also how I set up the post-processor for my machine. Okay, I will catch you next time. Until then, take care.